This is 118 point. The reciprocal of focal length expressed in meters of a lens is called power. Okay. So f focal length, it is in meters. మీకు ప్రాబ్లం ఇచ్చినప్పుడు ఫోకల్ లెంత్ని సెంటీమీటర్స్లో ఇస్తారు, కంపల్సరీ మీటర్స్లో కన్వర్ట్ చేయాలి. పవర్ ఈజ్ ఈక్వల్ టు 1/, ఫోకల్ లెంత్. ఈ ఫోకల్ లెంత్ అనేది మీకు ప్రాబ్లమ్స్ ఇచ్చినప్పుడు సెంటీమీటర్స్లో ఉంటుంది, దాన్ని కంపల్సరీ మీటర్స్లో కన్వర్ట్ చేసి ఇందులో సబ్స్టిట్యూట్ చేయండి, అప్పుడు పవర్ వస్తుంది. ఓకే, యూనిట్స్ ఆఫ్ పవర్, డయాప్చర్ D. The power of converging lens is positive. Converging lens means, so here converging lens means convex lens. Convex lens ki power is positive. Diverging lens, for diverging lens means concave lens. For concave lens, power is negative. Okay, so finally the power of a lens is the reciprocal of focal length. Okay, in the next point, so this is one example problem. The power of convex lens of focal length 25 centimeters. So here given focal length, given focal length f is equal to 25 centimeters. దీన్ని కంపల్సరీ మీటర్స్లో కన్వర్ట్ చేయాలి. 25 into 10 to the power of -2 meters. What is the formula for power? Power is equal to reciprocal of focal length 1/f. ఇందులో సబ్స్టిట్యూట్ చేద్దాం. సో పవర్ ఈజ్ ఈక్వల్ టు 1/25 into 10 to the power of -2. 10 to the power of -2 పైకి వెళ్తే 10 square means 100. 100 by 25, that is equal to 4. The unit of power is diopter. Its symbol is capital D. Okay. Okay, this is the topic of combination of lenses. When two lenses are separated by a distance D, these two are convex lenses. It is one convex lens, its focal length f1, another convex lens, its focal length f2. The separation between these two is D. What is the effective focal length? The formula for effective focal length 1/Fe. Fe means effective focal length. Effective focal length. The formula for effective focal length is 1/f1 plus 1/f2 minus D upon f1 f2. Please memorize this formula. Okay. What is the formula for power? 1/Fe ni P effective. Okay, దీన్ని పవర్లో కూడా రాసుకోవచ్చు. ఈజ్ ఈక్వల్ టు 1/f1 means P1. P1 is power of this one plus 1/f2 P2 minus D times 1/f1 P1, 1/f2 P2. So this is the formula for power. Okay, right. If the above two lenses are kept in contact, ఈ రెండు లెన్సుల్ని ఒకదానికొకటి టచ్ చేసినప్పుడు D 0 అయిపోతుంది కదా. Here D is equal to 0 when two lenses are kept in contact. So in this situation, what are the formulas for effective focal length and effective power? ఈ పైన ఉన్న ఫార్ములాలో D ప్లేస్లో 0 సబ్స్టిట్యూట్ చేస్తే సరిపోతుంది. సో 1/Fe is equal to 1/f1 plus 1/f2. Okay, in the place of D, 0 upon something is 0. Next, power. So this is one formula. Power of effective power is equal to 1/f1 P1 plus 1/f2 P2. Okay, right. For suppose if one lens is convex lens and another lens is concave lens, what is the formulas? Here 1/effective focal length is equal to 1 upon f1 plus 1 upon f2. So this is the concave lens, so its focal length is negative. For concave lens, focal length negative. కాబట్టి ఇక్కడ f2 ప్లేస్లో -f2 minus d upon f1, its focal length positive, into f2 minus f2. 1 upon fe is equal to 1 upon f1 minus of plus minus 1 upon f2 minus of minus plus d upon f1 f2. So this is the formula. ఓకే, ఈ ఫార్ములాకి దీనికి డిఫరెన్స్ ఏంటంటే ప్లస్ మైనస్ షిఫ్ట్ అయినాయి. ఇక్కడున్న మైనస్ ఇటు వచ్చింది, ప్లస్ ఇటు. సో ద ప్లస్ అండ్ మైనస్ ఆర్ షిఫ్టెడ్. వాట్ ఈజ్ ఫోకల్ పవర్? రైట్, ఎఫెక్టివ్ పవర్ ఈజ్ ఈక్వల్ టు 1 upon f1 p1 minus 1 upon f2 p2 plus d p1 p2. So this is the effective power. If these two lenses are kept in contact, the d becomes to 0. So substitute d0 in the above two formulas. What happens? 1 upon effective focal length is equal to 1 upon f1 minus 1 upon f2. 1 upon f2, this term becomes to 0. Similarly, focal power, effective power is equal to p1 minus p2. When d becomes to 0, this term becomes to 0. So this is the effective power. Two lenses having focal length 10 cm and 30 cm, convex and concave lenses. One is convex lens. So this is convex lens. Its focal length f1 is equal to 10 cm. This is another lens, concave lens. One is convex lens, its focal length 10 cm. Another one is concave lens, its focal length 30 centimeters. f2 is equal to 30 centimeters. Okay, separated by distance 20 centimeters. The separation between their centers is 20 centimeters. d is equal to 20 centimeters. What is the effective focal length? So the formula for convex and concave lens is 1 upon fe is equal to 1 upon f1 minus 1 upon f2 plus d upon f1 f2. For suppose if both are convex lenses, here plus, at this place minus. Okay, substitute these two values in this formula. 1 upon fe is equal to 1 upon first focal length 10 minus 1 upon second focal length 30 plus d is 20 centimeters. So 20 upon f1 f2 10 into 30. Okay, that is equal to 1 upon 10 minus 1 upon 30. Okay, right, 0 cancel, plus 2 upon 30. LCM is 30. 10 3s 3 minus 30 1s 1 plus 2. Okay, that is equal to 3 minus 1 2 plus 2 4 upon 30. Right, that is 4 upon 30. This is 1 upon fe. So therefore fe is equal to 30 upon 4, 7.5 centimeter. Okay, so this is the answer. Next, so this is another problem. Two convex lenses of focal length 20 centimeter and 30 centimeter. Here both lenses are convex. So this is convex lens, this is another convex lens. Both are convex lenses. Optic axis, their optic axis. The focal length of this one is f1 is equal to 20 centimeter. The focal length of second one f2 is equal to 30 centimeter. Okay, so this is the principal axis. The separation between the centers is 50 centimeters. So 50 centimeters is the distance between two lenses. Now the effective focal length of the combination. The formula for effective length of combination 1 upon Fe is equal to, both are convex lenses, so 1 upon F1 plus 1 upon F2 minus D upon F1 F2. Okay, that is equal to 1 upon F1 is 20 plus 1 upon F2 is 30 minus D, distance between the lenses 50 upon F1 20 times F2 30. That is equal to, here 0 0 cancel, 1 upon 20 plus 1 upon 30 minus 5, after cancellation 1 upon 20 plus 1 upon 30 minus 5 upon 60, 5 upon 60, 0 0 cancel, 5 upon 60, that is equal to, here 60, 21s 23s 3 plus 31s 32s 2 minus 5, so 0 0 upon 60. Here 0 upon 60 is 0 0. 1 upon effective focal length is 0, therefore effective focal length Fe is equal to infinity. 1 upon 0 infinity. Here the effective focal length is infinity.